Greetings, this is Anthony Dick, and I'm just going to walk through this practice test with you. Unit 1 Polynomials Practice Test. Show all the work when applicable and circle your final answer so we know what it is. Given the expression 2x to the fourth plus 20x squared minus 6x minus 9, identify the following. Coefficients. Okay, the coefficients, these numbers in front. So 2, positive 20, negative 6. Now, negative 9 is not a coefficient because it doesn't have an x on it. It has a negative 9. There's my answer. There's my answer. How many terms are there? Well, there's 1, 2, 3, 4 terms. Terms are separated by addition, subtraction. Okay. Next one. Given this expression, 9x squared plus 5x to the eighth minus 7x plus 10 minus 6x to the sixth, do the following. Write it in standard form. Standard form says we're going to take the biggest exponent thing, which is that 5x to the eighth, and I'm going to put that first. So I've used that. Then I do the next highest one, which is this minus 6x to the sixth. And then the next one is, this 9x squared. So plus 9x squared. And the next one is this minus 7x. And the next one is that plus 10. Okay, there. The degree of that polynomial, well, that's the highest exponent. It's 8. The leading coefficient. When it is in standard form, the leading coefficient is this number in front, in the very front. So it's positive 5. Okay, and there's my answer, there's my answer, there's my answer. Okay, for problems 3 to 10, it says simplify the expression, write your answer in standard form. Okay, so a couple of things. I've got this polynomial plus this polynomial. So because they're added, I don't need to change any signs. All I do is combine like terms. So 10x squared is a lot like the negative 9x squared. This negative 6 is like the negative 5. And this positive 4x is like x. Okay, so I'm thinking ahead. And I need to find the highest exponent, which is the 9x squared. So I go, well, what's negative 9x squared plus 10? Well, negative 9 plus 10 is 1x squared. Okay, so that's done. The next one is the x's. X plus 4x. Well, that's a 1x plus 4x makes positive 5x. And so that one's done. Negative 6 and negative 5 combine to make negative 11. And I really don't need that 1, so my answer is just x squared plus 5x minus 11. And there it is. Go up to 4. 4. 6x plus 7 minus 5x squared minus this. Now, the minus is just going to change the signs of everything here. So this minus, change it there. This becomes a negative 4x squared. This plus minus 3 becomes a negative 3. And this plus 10x becomes a minus 10x. Remember, when you're subtracting polynomials, you just change all the signs in that's being subtracted. So now we got to go back to like terms. So that's like that, and they're the highest ones. Negative 5 minus 4 makes a negative 9, and it's still x squared. Minus 10x is like 6x. Those are like terms. 6 minus 10 is negative 4x, and that's done. And then negative 3 is like the positive 7. Positive 7 minus 3 is plus 4. And there is my answer. Cool. Okay, now this one. Wow, this has got addition and subtraction. I'm just going to focus on the addition right now. I'll combine these. The highest exponent is negative 7x to the fourth, and there's nothing like it here. I'm going to ignore this over here for a moment. So I have negative 7x to the fourth. That's done. Now we're looking for any cubes, because that would be, there's one, 2x cubed. And there's nothing else like that, so plus 2x cubed. X squared, there's 3x squared plus 1x squared. So 3 plus 1 makes positive 4x squared. And I've got negative 6x and negative 9x. Those are alike. So negative 6 minus 9 makes negative 15x. Now this negative, so all these are done now. And this negative is going to change all of these signs. So I'll change that. Change this to negative 2x squared. it will change this positive to a minus, so minus 2x cubed, and this minus 5 to a positive 5, so plus 5. Now we just need to look for like terms. I apologize, my hand was covering up. Negative 7x to the fourth. There's nothing else like that. So that's done. 2x cubed. Oh, I saw one. Minus 2x cubed. Well, 2 minus 2 is nothing. So those cancel each other out. Okay. 4x squared is like minus 2x squared. 4x squared minus 2x squared is positive 2x squared. Good. Negative 15x is like positive 5. Oh, no, it's not, because the negative 15x has an x, and the positive 5 doesn't. So those are not alike, and they're just going to finish things off, and there's my answer. Cool. Number 6, I've got to multiply, simplifying by multiply. So that means I've got to distribute there to there. So negative 9x times x squared, I multiply the numbers. Negative 9 times 1 is negative 9. X times x squared gives me x cubed. And then I go negative 9 times negative 5. Negative times a negative is positive, and I get 45x squared. Negative 9 times negative 2. Negative times a negative is positive. 9 times 2 is 18, and the x tags along, and that's it. Okay. 3x plus 2 squared. The biggest mistake here is people just square that and call it good. But really, you got to think 3x plus 2 squared means 3x plus 2 times 3x plus 2. So if I go 3x times 3x, that's 9x squared. 3x times 2 is positive 6x. And then I have to distribute this. 2 times 3x is positive 6x. 2 times 2 is positive 4. These are alike. And so I have 9x squared plus 12x plus 4. Cool. Now this one. This one I don't like because it's going to be long, I think. But I'm just going to distribute all of this into this. So let's start. 4x squared times 2x squared. Well, 4 times 2 is 8. And x squared times x squared, I add the exponents and I get x to the fourth. 4x squared times negative x. 4 times negative is going to be a negative 4. And x squared times x is x cubed. Remember, I multiply the numbers, add the coefficients. Or add the exponents, rather. 4 times negative 6 is negative 24. And x squared just tags along. Now remember, I like to start piling up my like terms at this point. So I'm going to keep going. This one's checked. It's done. 2x times 2x squared. That's 2 times 2 is 4. X times x is x cubed. So positive 4x cubed. 2x times negative x. Well, 2 times negative is negative 2. And x times x is x squared. Kind of nice how those are lined up right there, huh? 2x times negative 6. 2 times negative 6 is negative 12. And there's the x. Okay, 5 times 2x squared, that's 10x squared. 5 times negative x, that's negative 5x. 5 times negative 6 is negative 30. Combine all my like terms, and I get 8x to the fourth. Those cancel. Negative 24 minus 2, that's negative 26, plus 10 gives me negative 16x squared. Negative 12 minus 5 gives me negative 17x and minus 30. Okay, let's turn the page. Next page. Say hello, I'll know you're here. Okay. This one, division. Oh, goodness sake. Okay, so I'm going to do this tabularly. So I'm going to make my tables. I don't know if that'll be enough. I'll add more if I need to. So the first team goes here, and then I've got 10x minus 5 there. Okay, so I'm looking at 10 divided by 10 is 1. X cubed divided by x is x squared. Cool. Now I multiply. Negative 5 times x squared gives me negative 5x squared. So I've got negative 5x squared, and I need negative 75x squared. So I need to put another negative 70x squared up there. Oh, yuck. Well, negative 70 divided by 10 is negative 7, and x squared divided by x is x. Negative 7 times negative 5 is 35x, and I need 45x, so I need another 10x, because 35 plus 10 makes 45. So 10x divided by 10x gives me a positive 1. Negative 5 times 1 here is negative 5, and I need a negative 15. So I'm going to put another negative 10, and that becomes my remainder. So my answer is x squared, right up here, minus 7x plus 1, minus, there's my remainder, minus 10 over the 10x minus 5. And that is it. Okay, cool. Okay, this one. Make my table again. Tables, tables, tables. Da, 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 da. Okay, so I can go 10x plus 10 here, and here I've got 20x cubed in the first one. So 20 divided by 10 is 2. X squared cubed divided by x is x squared. 2x squared times 10 is 20x squared. Now I got 20x squared. I need negative 50. Well, negative 50 minus 20 gives me negative 70x squared. Yeah, 20 minus 70 is negative 50, so that's a check that I've done it right. Negative 70 divided by 10 is negative 7x. Yeah, x squared divided by x. Here we go. Negative 7x times 10 is negative 70x. So I've got negative 70x. I need negative 170, so I need a negative 100 more. Negative 100x divided by 10 is a positive 10. Yeah, 10 times 10. Oh, no, no, no. No, no, no. It's a negative 10 because 10 times negative 10x is going to give me the negative 100. There we go. Negative 10 times 10 is negative 100. And check that out. I've already got that. So that's it. And this is 2x squared minus 7x minus 10. That also tells me that this is a factor, which plays right into the next one, 11. It says use the remainder theorem. Remainder theorem says if I take this and I divide it by that and I get a remainder, then this is not a factor of that. But there's a quick way to check it. Remember, I find the 0 for this, which in this case is x equals negative 6, because negative 6 plus 6 makes 0. And I put that in to this, negative 6 cubed minus 3 times negative 6 squared minus 63 times negative 6 minus 54. And this is how I'd show my work. And then I just type it into a calculator. Negative 6 cubed, what was it? Minus 3 times negative 6 squared, minus 63 times a negative 6, check, minus 54, this gives me equals 0, which tells me x plus 6 is a factor. So this is my work, and there's the answer to the question. Okay, which of the following operations are closed sets for polynomials? Closed means if I, like addition, if I add a polynomial to a polynomial, I get a polynomial. Good. Subtraction, if I subtract a polynomial from a polynomial, I get a new polynomial. Good. Multiplication, if I multiply a polynomial by a polynomial, I get a new polynomial. Division, if I divide a polynomial by a polynomial, sometimes I get a polynomial, but like up here on number 9, I didn't, because that's not a polynomial. That's a fraction of polynomials. So division is not. So these are closed. Perfect. Okay, now I'm going to use this for all the rest of these. How many zeros does it have? The degree. Now be careful. This is not in standard form. There's the degree, 7. Okay? So I'm going to rewrite this in standard form for a second. Negative 6x to the 7th plus 4x to the 4th minus 5x plus 10. Okay? So 7 is the degree. That means it's going to have 7 zeros. Describe the end behavior. Well, the leading coefficient's negative, so it's going to go down to the right. And it's an odd degree, so which means it's going to be odd behavior, so it's going to go opposite direction, up to the left. Cool. 14. For this polynomial graphed below, what's the degree? Well, I see 1, 2, 3 zeros, so it's 3. Just because there's 3 zeros. Okay. Is the leading coefficient positive or negative? It is negative because it's going down to the right. Identify the zeros. Well, the zeros are 1, 2, 3, 4, negative 4, 0, and 1, 2, 3, 4, 5. So if I write it in factored form, every one of these zeros has a factor. So x minus the negative 4, x minus the 0, and x minus 5. Now I can simplify this. X minus negative 4, that's just x plus 4. X minus 0 is just x, and x minus 5. And it doesn't matter the order I have those in as long as I've got all of them. Cool. Turn the test over. Okay. For this polynomial, answer questions about the polynomial. 15. What's the degree? Well, I see 2, 3, 4, 5. The degree are these exponents added together. So 2 plus 3 is 5 plus 2 is 7. Describe the end behavior. Well, it's positive there, so it's going up to the right. And it's an odd degree, so it's odd behavior down to the left. The zeros. There are 1, 2, 3 factors here. So every one of those factors has a 0. So the first one is 0. This x plus 4, it's going to be a minus 4. And this x minus 1, that's going to be a positive 1. And I don't need this one because there are only 3 zeros. Multiplicity. The multiplicity is the exponent here. So here it's 2. So let me scroll up here, pan out so I can see the whole thing. Here it's 2. There it's 3. Here it's 2. And whenever it's even, it's going to touch it. And that's odd, it's going to cross it. Okay? So what that tells me is I have a 0, 0, a 0 at negative 4, 1, 2, 3, 4 right there, a 0 at 1 right there. The end behavior is this, so up to the right, down to the left. So from this, I'm going to go up to the right. Here, I'll go down to the left. So the ends, you pick from the right 0 and the left 0. Now, what's it going to do here at 1? At 1, as I says, it's going to touch it. So it's going to touch it. And then at 0, it's going to touch it again. So touch, comes down to 0, touch it. And it's got to cross there at negative 4. Okay, and there's my graph. Next one. What's the degree? Well, I see 2, and there's a 1 and a 1. So 2, 3, 4. Degree is 4. That negative 3 doesn't have a variable, so it doesn't have anything to do with the degree. Describe the end behavior, but it does have to do with the end behavior. It's negative in front, so it's going to go down to the right, and it's even degree, so it's going to be the same on the left. Now this has 1, 2, 3 factors, so it's going to have 3 zeros. This is at 4, and as long as I'm here, multiplicity of 2, and since it's an even multiplicity, it's going to touch. This, x plus 3. Negative 3 is the factor. It's an exponent of 1, so that's its multiplicity, and 1 is an odd number, so it's going to cross. X plus 5. Negative 5 is the opposite of that, so that's the 0. Has a multiplicity of 1, since that's a factor, and 1 is an odd number, so it's going to cross. Now, if I graph this, I have a 0 at 4, 1, 2, 3, 4. A 0 at negative 3, 1, 2, 3. A 0 at negative 5. And the end behavior from up here above, it's going to go down to the right, down to the left. So here at negative 5, I say I'm going to cross. So I'm going to cross here. And then here at negative 3, it's going to cross there. So cross it, cross it. Now the only thing left is to touch there because it's got to bounce. So it's going to touch there. And there it is. Cool. Last page for a moment. Draw the graph of a fourth degree polynomial with 2 real roots. So 2 real roots says it's got to cross somewhere in 2 places. So I'm just going to put 2 random places there. Fourth degree tells me it's either going to be doing that or that, and I really don't care. So I'm just going to go there and there. That's not the only graph I could have made, but that's good enough. Okay. 18 is like a box problem. An open box is made from a 15 by 17 piece of copper by cutting equal squares, x inches, so x and x, x and x, x and x, x and x. And I'm going to make it into a box. So now this isn't 15 anymore. It's 15 minus 2x. So I took away an x there and an x there. This isn't 17 anymore. It's 17, take away 2x. So I took away an x from there and there. So write a function representing the volume of the box. Well, the box is going to look like this. And there's my side that I folded up. And the 12 minus 2x is here. 17 minus 2x. And I got 15 minus 2x. So it's going to be x and 15 minus 2x and 17 minus 2x. Okay? Now, it says, what's the maximum volume of the box? When I graph this, I'm going to get a graph that looks like that. Now, this represents negative volumes. Can't do it. Same way here. This represents squares that are too big to be cut out. I'm looking for this point here. And if you graph this on Desmos, I'm just going to pull up my Desmos and see what I get here. And I select that maximum. So I'm graphing x times 15 minus 2x times 17 minus 2x. You're just going to have to do this on your own on Desmos. And I get this graph. I'm having to scroll up and zoom out for a little bit, but I finally found it. I get the point, and I'm going to round this to one decimal place, 2.7 and 300.7. Okay, now the maximum volume is the y value here. So it's 300.7 cubic inches. That's the maximum volume. This is the size of the square that gets cut out. Okay? This is the size of the square that gets cut out. That's the maximum volume. So here is my answer. I'll just make sure I go circle through all my answers there. And it's going to be good. Guys, that's a walk through the test. I know it's quick, but you can slow it down and rewatch things. See you next time.